Long short-term memory (LSTM). Long short-term memory (LSTM) networks are a type of RNN specifically designed to capture long-term dependencies in sequential data. LSTMs use gating mechanisms to control the flow of information, which helps prevent the vanishing gradient problem that standard RNNs suffer from. They are commonly used in tasks like language modeling, machine translation, and time series prediction. We did implement RNN in the previous video. In this one, we are going to do LSTM, which is almost similar to that code, but I'll still go through each and every line in Python implementing LSTM. So let's go ahead and write that code. So I have already created a file called as lstm.py. I'm going to start with importing the libraries. I have imported TensorFlow as TF, the main library for deep learning, providing tools for defining and training neural networks. We have layers and models. These are Keras modules which TensorFlow used to define layers and models for deep learning. IMDb is the dataset of movie reviews for sentiment analysis provided by TensorFlow's Keras module, where each review is labeled as either positive or negative. And then sequence, a utility for pre-processing sequences used here for padding or truncating sequences to a fixed length. Next, let's load and pre-process the IMDb dataset where we have max features of 10,000 and max length is 500, same as last project, where max features sets the vocabulary size to the top 10,000 most frequent words in the dataset. Words outside this range will be ignored. Max length sets the maximum length of each movie review to 500 words. Reviews longer than 500 words will be truncated, while shorter ones will be padded. Next, I'm going to have xtrain, ytrain, xtest, ytest equal to IMDb, load data number of words equal to max features. This loads the IMDb dataset limited to the max features most frequent words. Xtrain, ytrain is a training data and labels where each review is represented as a sequence of word indices. Xtest, ytest are the testing data and labels. So let's go get xtrain equal to sequence.pad sequences, xtrain comma max length equal to max length. This pads or truncates each review in the xtrain to make all reviews exactly max length 500 words in length. Similarly, for test, we run the same command sequence.pad sequences xtest max length equal to max length. Similarly, pads or truncates xtest reviews to a uniform length. This step is necessary for efficient batch processing in neural networks. Now is the real LSTM model. So let's define the LSTM model. Model equal to model.sequential. This creates a sequential model where each layer's output is fed directly into the next. Layers.embedding max features 32, input length equal to max length. Embedding layers that converts word indices into dense vectors of fixed size. The max features again is the limits the embedding layer to the top 10,000 most frequent words. 32 is the sets the size of each word vector to 32 dimensions, and input length equal to max length defines the max length of input sequences to 500 words, ensuring all inputs are consistent in shape. Now let's go ahead, and here is where we add LSTM. Layers.lstm 32. Long short-term memory LSTM layers with 32 units. LSTMs are designed to capture sequential dependencies in the data, making them well suited for text. Layers.dense 1, activation sigmoid. Fully connected output layers with one neuron and a sigmoid activation function. One here is a single output neuron predicting the probability of positive or negative sentiment. Activation equal to sigmoid is a sigmoid function to output a probability between 0 and 1 suitable for binary classification. Next, let's go ahead, close it, and compile the model. When I compile the model, I'm going to say model.compile. Again, I'm going to use the same things: optimizer equal to Adam, loss equal to binary cross entropy, and metrics equal to accuracy. Where model.compile configures the model for training, optimizer Adam uses the Adam optimizer, which adjusts learning rates dynamically and is widely used for deep learning. Loss equal to binary cross entropy is binary cross entropy loss, which is appropriate for binary classification task. And finally, metrics equal to accuracy tracks the accuracy during the training and evaluation. Let's go ahead and train the model now. So train the model, model.fit, pass xtrain, ytrain, epochs equal to 5, batch size 64, validation split equal to 0.2. Here xtrain and ytrain are the training data and labels, epochs equal to 5 is number of times the model will iterate over the entire training data set. Batch size equal to 64, number of samples processed per training batch. This helps manage memory and improve computational efficiency. Validation split equal to 0.2 reserves 20% of the training data for validation, allowing the model to evaluate performance on a validation set after each epoch. And now let's go ahead and evaluate the model. Test loss, test accuracy equal to model dot evaluate x test y test. This evaluates the model on the test set, returning the test loss and accuracy. X test and y test here are the test data and labels. Test loss is the loss computed on the test data. Test accuracy is the accuracy achieved by model on the test set. Let's go ahead and print our test accuracy, which prints the test accuracy showing the model generalization performance on unseen data. I'm going to save this, open my command prompt and say python lstm.py. Again, it's going to run for 5 epochs. So I'm going to, as soon as it starts with the first epoch, I'm going to pause it and fast forward to the 5th epoch. So now that we are done with our 5 epochs, we can see the value accuracy at the end of it was, depending on each epoch, you see it's an average of 86%. And now we're going to probably test the final accuracy, which is around 86%. With RNNs, it was 81%, whereas with LSTM, it's 86%. If you've not seen the RNN video, you can go to the previous one and check it out. But as you can see, with LSTM, we got a better accuracy from the fifth for the same data set for IMDb. If you are able to solve this, perfect. If not, if you had any issues, errors, or problems, let me know in the comments and I'll get back to you.